rainfall simulator, people ask me, well, you know, the details, you know, the drop size the same, the right, etc. How much pressure, Dr. Paul Yassa, this is his baby. So he's the inventor. About 1991-92, he came up with this idea. It's being commercially made now, but this is pretty close to what you see his original design. Okay, so that raindrop size, as it's falling, is approximate, and then at some point that raindrop hits the soil surface, has a lot of energy, dislodges, detaches that soil particle, it bounces up in the air, and then at some point it goes into what we call transport. And if it's being transported at that point, it could be deposited either locally within a few feet, a few hundred feet downslope, off the field. It could be end up in a lake, river, or stream. I mean, that's what happens. That whole process is called water erosion. Okay? And while I described that process to you, that process started to occur on what sample? Conventionally tilled, right? Why? That raindrop energy hit the soil surface, detached the soil particle, away we went, right? Now, how do you stop erosion? Stop detachment. How do you do that? You get something in the way. You stop that kinetic energy from hitting the soil surface, and you do that by what? Crop residues, litter on the surface, crop canopy, something absorbs that energy before that raindrop hits the soil surface. And if it does, it stops detachment, stops erosion. You can see that in these other samples here, but that detachment process, you can see that here on this white backboard. See the bounce? That detached soil particle bounces up, but you don't see that over here. Why? Something's in the way. Something is absorbing that energy, right? So at some point when we talk about that, you need to understand that it's not rocket science. We can stop this process from occurring, but we need to keep soil covered. I believe that's one of the principles. Right, Jay? Yep, there you go. So anyway, it's